this video has sound. Hopefully everybody can hear my voice. If not, hopefully they are reading this sign and getting the sound up and running. Okay, this lesson is on Chapter 7, Section 4, Part 2, out of the Geometry Chapter 7 Study Guide. This lesson is on a special type of right triangle called a 30, 60, 90 triangle. It is named that way because the angles in the interior of the triangle are 30 degrees, 60 degrees, and 90 degrees. What we're going to be working with is the relationship between the lengths of these sides, and we have to identify them first in order to do that. First, we'll find the shortest side. The shortest side is always going to be directly across from the smallest angle, 30 degrees. So this would be the shorter side right here. This is obviously the hypotenuse. It's always the longest side, so I'm just going to abbreviate that HYP. And then the two legs, there's going to be the shorter leg and then the longer leg. Remember, the legs are the two sides on your right triangle that come together to make the 90-degree angle. So the longer leg on this particular diagram would be that one. It is always across from the 60-degree angle. So the relationships of these sides is as follows. The hypotenuse is going to be twice, 2 times, as long as the shorter leg. So as you can see in the first example, this is my shorter leg, this is my longer leg, and this is my hypotenuse, right? So the hypotenuse being twice as long as the shorter leg, if this is 2, wouldn't this be 4 right here? Because it's twice as long? Yeah, it would. Or the other relationship here is that the longer leg is going to be the shorter leg times the square root of 3. So for example, in number 7, if we're trying to find the longer leg, but we know that the shorter leg is 2, all we have to do is multiply that by the square root of 3 to find the longer leg. So this one would be 2 times the square root of 3. So they break it down into little formulas here. The first one says the hypotenuse is twice the shorter leg, so 2 times the shorter leg. And the longer leg is the shorter leg times the square root of 3. So in case you forget, here are your equations. Right there. Okay, so it gets a little more complicated when they don't give you the short leg as the first value that is given. So for example, here they gave us the hypotenuse, right? This one is my short leg. I know that because not only that it looks like the short one, but it's across from the 30-degree angle. That's how I know that's my shorter one. And that must mean this is my longer leg. So, all right, so let's try to find x first. X would be my short leg, and according to this first formula, the hypotenuse equals 2 times the shorter leg, right? So if my hypotenuse is 6, and we're trying to find the shorter leg, which is marked as x, then if I solve this equation, 2x equals 6, I can find x. Well, that's not so hard. I just divide both sides by 2, and x equals 3. Oh. Well, now how do we find the longer leg? Well, here's the formula that includes the longer leg. It says the longer leg equals the shorter leg times the square root of 3. It's right there. Okay, well the shorter leg, we just found that to be 3. So the longer leg must be 3 times the square root of 3. Well, you can't exactly multiply them together and get something different. There's no way to simplify that. You just write it as 3 root 3. So the longer leg being y, that's our answer for our y, 3 root 3. This one down here doesn't really have a number. I'm going to call it number 9. And as you can see, we have a triangle here. I recognize this as a right triangle because if this side over here is perpendicular, then this side over here would be perpendicular, and this line come together. So I do have a right triangle. I know it's 30, 60, 90. If this is 90 and this is 60, then this corner would have to be 30, because I know they would all add up to 180, so that's only 30 degrees left over. So across from my 30-degree angle, that's my short side, or short leg, I should say. Across from my 60-degree angle is my long leg, and then across from my 90-degree angle is the hypotenuse. So I'm assuming here they want me to find A and B. I do know that the longest leg is 6 because this is a square. So I'll have to find my short leg and my hypotenuse based on the long leg. The formula up at the top says longer leg equals shorter leg times the square root of 3. I'm going to start with that one because the first formula, I don't know either one of these values. For the second formula, at least I know this one. So I'm going to start with that. Long leg, it says, equals the shorter leg times the square root of 3. Okay, well the shorter leg, they're calling that B. I don't know what that is yet. And the longer leg is 6. So basically what I have is 6 equals B times the square root of 3. Or you could call it root 3B. So solving for B, I like to kind of flip this equation around. Square root of 3B equals 6. And then divide both sides by the square root of 3. So B equals 6 divided by root 3. Now we can't leave our answer like that. The reason for that is that we can't have answers where the fractions have a square root in the bottom, in the denominator. So what I'm going to do is I'm going to try to simplify this. We learned how to do this in the previous sections, but I'll show you again. The square root of 3 is our denominator radical that we want to eliminate. So what we're going to do is we're going to multiply on the top and the bottom by whatever that square root is. Multiplying straight across the top, we get 6 root 3. Straight across the bottom, we get the square root of 9. The square root of 9 is actually just plain old 3. And then if we can do any division, we should. 6 divided by 3 is 2. Square root of 3, bring that along on your answer. So I found out that side B, that's my short leg, is 2 root 3 in length. Finding the hypotenuse shouldn't be too hard. The formula up at the top says that if you take your hypotenuse, that's equal to twice the length of the short side, right? So our short side, we just found that length to be 2 root 3. So we can multiply the regular numbers together. 2 times 2 is 4. Then we bring along the root 3 for the right. So the hypotenuse, which they're calling A, is 4 root 3 in length. Okay. On the next page, they have several questions for us. This column represents one question. They give you side A and they want you to find the lengths of sides B and C. This next column is the next question. They give you side length B and they want you to find lengths A and C. And here's another question. They give you side length B and they want you to find lengths A and C, and so on. So depending on what they give us, some of these questions, and there's 5 of them, 1, 2, 3, 4, 5, some of them will be easier and some of them will be harder. So let's start with the first column. They gave us the short side, I keep saying that, the shorter leg. B is the longer leg, and then C is the hypotenuse. So if they give you the shorter leg, that'll be faster because our formulas are kind of based on knowing that first. At least it makes it easier when you know that first. So this one, if the shorter side is A, then the longer side is whatever that length is times the square root of 3. So B would be 9 root 3. The hypotenuse is just the shorter side doubled. So if the short side is 9, then the hypotenuse is 18. Same thing for this column. The short side, if we multiply it by the square root of 3, we get the long side, so that would be 11 root 3. And the short side doubled gives you the hypotenuse. In this case, 11 times 2 is 22. If the hypotenuse is 16, we have a short side that would be half as big, right? I mean, saying that take this number and multiply it by 2 is the same relationship as saying take this number and divide it in half to get that one, right? So if this is 16, the hypotenuse, then the short side would be half as big, which would make it 8. And then the relationship between the short side, shorter leg, and the longer leg is you just take your short leg and you multiply it by the square root of 3. So this becomes 8 root 3. Now I just did all that without really showing any work. It's just the basic relationship, and since these numbers were easy to work with, it wasn't so hard at all. Now it's going to get a little bit harder. This one is 5 root 3. That means I must have taken the short side and multiplied it by the square root of 3, which means the short side must be 5, right? 5 times the square root of 3 would be 5 root 3, yeah. And then knowing that the short side is 5 and the hypotenuse is double that, 5 times 2 would give me 10. Again, I just did that using basic mental math. Did it in my head. And explained it out loud. Now this one's a little harder. This one basically gives you the long side, and the first thing I would do is find the short side. So I know the relationship between the long leg and the short leg is that if you want to find the longer leg, that's the same as taking the shorter leg and multiplying it by the square root of 3, right? So if I know the longer leg is 9, and the shorter leg, let's call that A, I could say that I have 9 equals the square root of 3A. Switching that around, square root of 3A on the left and the 9 on the right, you can do that. I want to solve this by dividing both sides by the square root of 3. So that gives me A equals 9 divided by the square root of 3. And we can't leave our answer like that because when you have fractions, you can't leave the denominator value as a radical. So what we're going to do is we're going to multiply on the top and the bottom by the square root of 3. Because that's the radical we have, square root of 3, in the denominator. Multiplying straight across, the top is 9 root 3. And the bottom is the square root of 3 times the square root of 3, which is the square root of 9. The square root of 9 is actually a simpler number. It can be written as just plain old 3. Square root of 9 is 3. And then finally we can divide here. 9 divided by 3 is 3. And then the square root of 3 just stays the square root of 3 on the side. So after all that, A, in this second example, is 3 root 3. The hypotenuse here is going to be twice as big as this. So if I take this number and multiply it by 2, I get 6 root 3. All right, now I'm not going to do both parts A and B down here. I'm just going to do part A. Okay, so this is a skateboard ramp. It's got, you know, some underlying structure here, and then this is the surface that's on the top. And the side here, they're trying to tell us that this is a 30, 60, 90 triangle. This angle is 30. This angle they've marked at 90 degrees, which means that this corner up here would have to be 60. Okay. So if they want us to find side A right here, we can do that using the same properties that we practiced on in this section. Side A is the longer leg, and this side right here is the shorter leg. We know the relationship between the long leg and the short leg is, to find the long leg, you just take your short leg and multiply it by the square root of 3, right? So our long leg, which they've labeled A, side A, is the short leg, which we know is 56 centimeters. We multiply that by the square root of 3, well, there you go, 56 root 3. Now, they do want us to write it in centimeters, and they want us to round off to the nearest centimeter, so that means I'm going to have to get my calculator out here, and I'm going to multiply 56 times the square root of 3. You might want to find the square root of 3 first and then multiply that decimal by 56. Anyway, I get approximately 96.9948 and so on centimeters. So that means to the nearest centimeter, that would be 97. Side B is the hypotenuse here. See that? This is side B. Side B was lifted off, but basically it started off down here. So side B is the hypotenuse. So if we want to find that, we know the shorter side is 56 root 3. So the hypotenuse is the short side times 2. So the hypotenuse, which is actually B, side B, in our diagram, so I'm going to call it that specific name, is the short side, which is 56 root 3 times 2. So side B ends up being 112 times root 3. Oh, I'm sorry. The short side is 56, not 56 root 3. There we go. I was using the long side, not the short side over here. So the short side is just regular 56. And if we multiply that by 2, you get 112. I was sensing I was making some sort of silly mistake. There we go. I grabbed the wrong number. Short side is 56. Okay. So side B is 112 centimeters long. Now, here's the weird part. If you look at the diagram, this part that's been lifted off, you look at this triangle right here, see how it says 45, 45 in the corners? That means that this side right here, side B, actually has to be the same as this side right here, side D, because every 45, 45, 90 triangle is isosceles. These two legs that come together to make your 90-degree angle have to be equal to each other in length. The only reason why it doesn't look that way is that the perspective that they drew it at, you know, they're not holding it, you know, to you, they're holding it kind of at a weird angle. So it doesn't look that way. But because we know that the properties of a 45, 45, 90 triangle are as such, that these two sides would have to be the same because this is an isosceles triangle, we would then have to determine that side D is also 112 centimeters. So finally, side C is the hypotenuse on a 45-90 triangle. 45-45-90 triangle. And the hypotenuse there is just the length of one of the legs multiplied by the square root of 2. If you don't remember that, you can go back to the video on 7.4.1 on 45-45-90 triangles. Anyway, if you take that side length and multiply it by the square root of 2, you get the hypotenuse, which is C, to be 112 times the square root of 2 centimeters. Now they want us to round this off to the nearest centimeter. So if I take 112 times the square root of 2, I get approximately 158.39 on my calculator, which rounded to the nearest centimeter would be 158 centimeters approximately.